Subscribe to the channel so you don't miss out on any of these videos. Picture this: a collision between two colossal galaxies, a galactic car crash so massive that it will alter the very fabric of our cosmic neighborhood. This isn't science fiction. It's not something that will happen in some far-off, unreal future. In fact, it's an event that will unfold over billions of years. But what does it mean for us, for the Milky Way, and for our solar system? Today, we're diving into one of the most fascinating and terrifying events in the universe: the collision between the Milky Way and the Andromeda galaxy. Imagine for a moment that you're standing on Earth, staring up at the night sky, seeing the Milky Way stretched across the darkness. It's beautiful, vast, and seemingly eternal. But what if I told you that in about 4 billion years, that same night sky will look completely different? It won't be the serene, quiet view you're used to. Instead, we'll be witnessing a cosmic event that will reshape everything we know. This is the story of the Andromeda collision. What will happen when our galaxies collide, and how will this alter the course of our existence? Hold on tight as we explore this mind-boggling phenomenon, unraveling the mysteries of this galactic encounter, its consequences, and what it means for our future in the universe. Let's start by answering one of the most pressing questions: how do we know that this collision is even going to happen? The simple answer lies in the precise measurements of the movement of galaxies. The Andromeda galaxy, our closest major galactic neighbor, is currently on a collision course with the Milky Way. This isn't a wild guess or a far-off hypothesis. It's a prediction based on observable evidence. Scientists have been able to measure the velocities of galaxies and track their movements for decades, using telescopes and advanced imaging technology to build accurate models of galactic motion. The Andromeda galaxy is about 2.5 million light-years away from us, which is a vast distance. But when you're talking about the scale of the universe, that's just next door. Despite its enormous distance, Andromeda is on a direct collision course with our Milky Way. And the mind-blowing thing is that this collision will take place in the far future, about 4 billion years from now. But even though this is a long way off, it's crucial to understand what will happen when these two massive galaxies collide and merge. The initial stages of the collision. At first, the collision won't be as dramatic as you might think. Both the Milky Way and Andromeda are made up of mostly empty space, with stars separated by vast distances. This means that when the two galaxies first start to collide, stars themselves won't actually collide. Instead, the gravitational pull between the two galaxies will begin to reshape them. The collision will be a slow process, taking millions of years to unfold. The first thing we can expect to see when this happens is an epic cosmic light show. As the galaxies begin to interact, their gas and dust clouds will start to collide and compress. This will trigger intense star formation, creating new stars at a rate far faster than anything we see today. For a brief period, the night sky will be filled with bursts of light as stars are born in this galactic merger. Imagine a sky filled with thousands, if not millions, of new stars lighting up the darkness. The gravitational dance, how the Milky Way and Andromeda will merge. After the initial impact, the two galaxies will begin to orbit one another. This is where things start to get really interesting. They won't just crash head-on in a simple collision. Instead, the gravitational forces will cause them to spiral around each other in a cosmic dance. Over the course of billions of years, the two galaxies will continue to pass through one another, their stars and gas clouds interacting with each orbit. During this phase, the shape of both galaxies will begin to change. The spiral arms of the Milky Way and Andromeda will begin to distort, slowly transforming into something completely new. The two galaxies will start to merge into one larger, elliptical galaxy, but this won't happen in a single event. It will take several passes, with each orbit bringing the galaxies closer together until they eventually merge into a single, larger galactic entity. As this process unfolds, the core of each galaxy will also begin to move closer to the center of the combined galaxy. Over time, the cores of both the Milky Way and Andromeda will eventually merge, forming a supermassive black hole at the heart of the new galaxy. This black hole will be far more massive than any we've observed in the current era, and it will play a major role in the fate of our galaxy. The gravitational influence of this new black hole will likely cause the stars and gas in the galaxy to move in complex ways, leading to further changes in the galaxy's structure. The fate of our solar system. You might be wondering, what does this mean for our solar system? After all, we're part of the Milky Way, and if the galaxy is going to collide with Andromeda, what will happen to us? Well, here's the interesting part. While the collision of the two galaxies will be a monumental event, the chances of our solar system colliding with another star during this process are incredibly small. As I mentioned earlier, galaxies are made up mostly of empty space, so the individual stars won't crash into each other. However, that doesn't mean that our solar system will come through this unscathed. The gravitational forces involved in the galactic merger will be so immense that they will likely send our solar system on a new trajectory. The orbits of stars will shift, and the entire structure of the Milky Way will be altered. Our solar system may be flung to a different part of the new, larger galaxy, and it could even be ejected from the galaxy altogether. This means that, in the distant future, Earth may no longer be part of the Milky Way at all. We could be part of a new, elliptical galaxy formed from the merger of Andromeda and the Milky Way, or we might even be expelled into intergalactic space. The gravitational interactions during this process will be so intense that it's impossible to predict exactly what will happen to us, but it's likely that life on Earth will be profoundly affected by the changes in our galactic environment. The merging of these galaxies will also cause a dramatic increase in cosmic radiation. The intense bursts of star formation and the collapse of gas clouds will produce massive amounts of radiation. While Earth is far enough from the center of the action to be shielded by the Sun, the increase in radiation could potentially have a major impact on the evolution of life on our planet. It could also affect the stability of our orbit around the Sun, but again, this is all speculative, though fascinating to think about. What happens after the collision? Once the Milky Way and Andromeda have fully merged, the resulting galaxy will be vastly different from the ones we know today. It will likely be an elliptical galaxy, a shape that's quite different from the spiral structure of our current Milky Way. The new galaxy will be much larger and more massive, and it will contain far more stars than either of the original galaxies. This will likely result in a more crowded cosmic environment, with stars packed closer together. The new galaxy will have a much higher stellar density, which could mean more frequent star collisions and supernovae. The core of the new galaxy will likely contain a supermassive black hole, even more massive than the ones currently located at the centers of the Milky Way and Andromeda. This black hole will be surrounded by a massive region of stars and gas, with powerful gravitational forces shaping the structure of the galaxy for billions of years to come. But it doesn't stop there. The merger of these two galaxies will also trigger the formation of new structures. Some of these could be massive stellar clusters, regions where stars are born at a rapid pace. The gas and dust that were once part of the Milky Way and Andromeda will be compressed during the collision, leading to the birth of new stars, planets, and possibly even life in entirely new parts of the galaxy. A cosmic event in the far future. As we wrap our minds around the sheer scale of the Andromeda collision, it's important to remember that this is an event that is far in the future. It's not something we need to worry about today, or even in the next few million years. But understanding this collision helps us grasp the immense scale of the universe, and how even the most stable and seemingly eternal objects in the cosmos are constantly evolving and changing. The Andromeda collision is a reminder that the universe is never static. Galaxies are constantly in motion, colliding, merging, and evolving over vast stretches of time. And while the effects of this collision will be felt on an unimaginable scale, it's part of the natural course of galactic evolution. The unseen consequences of the Andromeda collision. As we continue to explore the future of the Andromeda Milky Way collision, it's important to understand that while some of the most obvious consequences have been discussed, the new stars, the distorted galaxy shapes, the fate of our solar system, there are other far-reaching and perhaps more subtle effects we have yet to uncover. Even though the merger of these galaxies is bound to take billions of years, there are phenomena that may arise during the process that could have profound implications for life, physics, and our understanding of the universe itself. One aspect of the collision that hasn't been discussed as much is the possibility of the interaction between the supermassive black holes at the centers of both galaxies. When galaxies merge, the cores often interact in ways that are not only spectacular but also chaotic. As the galaxies collide, the gravitational pull between the two supermassive black holes will begin to increase, leading them toward each other. The gravitational forces between these two black holes will accelerate over time, and eventually, they could merge into a single, supermassive black hole at the center of the new galaxy. The energy released during such an event would be extraordinary, potentially leading to the creation of massive jets of radiation and high-energy particles that could have far-reaching effects on the entire galaxy. This cosmic event could send shockwaves through the fabric of space-time itself, creating ripples in the very structure of the universe. These ripples are known as gravitational waves, and the merging of supermassive black holes is one of the most powerful sources of gravitational waves that scientists study today. As the two black holes spiral towards one another, they will emit gravitational waves, ripples in spacetime that carry energy across vast distances. The merger of these black holes could release an enormous amount of energy in the form of gravitational waves, creating detectable signals across the universe. The study of these waves could reveal new insights into the behavior of black holes, the nature of gravity, and the very structure of spacetime itself. Stellar evolution, the creation of new stars. While the supermassive black holes may dominate the attention, the actual merging of the galaxies will also create new stars. In fact, it will lead to one of the most intense periods of star formation the universe has ever seen. The collision of gas clouds from the two galaxies will trigger massive bursts of star formation as the gas and dust clouds collapse under their own gravity. This will create entire star-forming regions, dense with young, hot stars that burn brightly in the cosmic darkness. These new stars will appear all over the newly merged galaxy, creating an entirely new stellar population. As these stars form, they will burn through their fuel at an accelerated rate, creating supernovae, the explosive deaths of massive stars that scatter elements throughout the galaxy. These supernovae will not only contribute to the next generation of stars but also release heavier elements like gold, iron, and uranium, which are essential for the formation of planets and life as we know it. The birth of new stars and the creation of new stellar systems could potentially result in the formation of new planetary systems. Depending on the local conditions, planets in these new systems could be located in habitable zones, where conditions might allow for life to develop, perhaps even in ways we cannot predict. The cosmic chaos caused by the galactic merger could ultimately give birth to new systems of planets, some of which might share similarities with our own solar system. However, it's crucial to remember that this process won't be smooth or immediate. The stars born in the wake of the collision will be subject to the turbulent conditions of the galactic merger. Some might be flung out of the galaxy altogether, while others could be pulled into the central black hole. Regardless of the outcome, the galactic collision will certainly lead to the creation of new, exotic regions of space, with the potential for new discoveries about the nature of stars, planets, and the forces that govern the universe. How will the collision change the structure of our solar system? By now, you're probably wondering what this means for our own solar system. How will the gravitational forces at play in this galactic collision affect Earth and the other planets orbiting our Sun? As mentioned earlier, the chances of individual stars within the Milky Way and Andromeda actually colliding are incredibly small due to the vast distances between them. But that doesn't mean that we're immune to the effects of the collision. The gravitational forces at work during the merger will cause the stars within both galaxies to shift and change their orbits. This could potentially move our solar system into a different part of the galaxy. Imagine that Earth is currently located in one of the spiral arms of the Milky Way, a relatively quiet and stable region. But when the galaxies collide, the gravitational forces will likely disturb the orbits of the stars, including our own Sun. Our solar system may be displaced from its current location and move toward a different part of the galaxy, or possibly even ejected from the galaxy entirely. This could send our solar system into a wandering journey through intergalactic space, where the effects of the collision would have far-reaching consequences. In such a scenario, Earth would be far away from the safety and stability that the galactic core provides. The Sun's gravitational influence would become less reliable as our solar system travels through new regions of space, possibly entering an area that's more hazardous due to higher radiation levels, stellar wind from nearby stars, and an increase in cosmic radiation. The changes in our solar system's orbit could also disrupt the conditions that make Earth habitable, especially if our planet is sent farther from the Sun, pushing it into a frozen, inhospitable state. Will life survive the galactic collision? While the physical changes to our solar system may be extreme, the question of whether life on Earth could survive such an event is equally intriguing. If the collision leads to a shift in our solar system's orbit, or even ejects it from the galaxy, the impact on Earth's environment could be catastrophic. The changes in radiation levels, combined with the movement into a potentially more hostile region of space, would create an extremely challenging environment for life. However, it's important to note that the collision itself won't immediately wipe out life on Earth. In fact, the effects of the galactic merger may not be immediately noticeable in our lifetime, or even in the lifetime of our descendants. It would take billions of years for the full effects to be felt, giving humanity and Earth plenty of time to adapt, or even migrate to other parts of the galaxy if technological advancements allow for space travel. In the short term, life on Earth would likely remain relatively unchanged. However, as the merger continues and the effects on our solar system become more pronounced, survival would depend on how well humanity can adapt to these changes. If we can harness space exploration and find ways to shield ourselves from cosmic radiation, migrate to other star systems, or even colonize new worlds, the human race might endure, despite the dramatic galactic transformations. But whether or not life as we know it can continue in the long run is still up for debate. The Andromeda Milky Way collision presents a series of unknowns that could change the course of human history. The collision will undoubtedly challenge our understanding of the universe, our place in it, and the potential for survival as a species in an ever-changing cosmos. The long-term future of the universe. The collision between Andromeda and the Milky Way is just one chapter in the ever-unfolding story of the universe. In fact, this galactic merger is a relatively small event in the grand scheme of things, happening over a period of billions of years. The long-term future of the universe is filled with even more mind-boggling events. In another few billion years, the universe itself may undergo even more drastic changes. For example, eventually, the expansion of the universe itself will likely reach a point where galaxies will be so far apart that we will no longer be able to see them. The light from distant galaxies will be redshifted beyond the point where we can detect it, leaving the universe a dark, cold place. Stars will burn out, and the universe will continue to expand into an increasingly empty space. And even though we're still billions of years away from that eventual fate, the collision between Andromeda and the Milky Way is just one of the many cosmic events that serve as a reminder that the universe is dynamic, always changing, and never static. The collision is a testament to the scale of the forces at work in the cosmos, and the impermanence of the galaxies and stars we see today. But as the universe continues to evolve, we will undoubtedly learn more about the forces that drive these cosmic events, and how we might survive them or understand them in ways we cannot even fathom yet. The Andromeda collision, and the merging of our galaxies, represents just one of the many mysteries that lie ahead in the cosmic future. As we explore further into the potential outcomes of the Andromeda Milky Way collision, we must also consider how this event will influence the larger cosmic environment. While we've focused mainly on the immediate consequences for the Milky Way, Andromeda, and our solar system, we must also broaden our scope and understand the far-reaching impacts on the surrounding galaxies and the cosmos at large. The cosmic web, the role of galaxy collisions in the universe. The Andromeda collision is not an isolated event. It is part of a much larger, more complex cosmic process. The universe is composed of a vast network of galaxies, clusters of galaxies, and enormous cosmic voids, all interconnected by what is known as the cosmic web. This web of galaxies and intergalactic filaments is shaped by the gravitational forces that govern the motion and behavior of cosmic structures. The collision between the Milky Way and Andromeda will have an effect not just on the two galaxies involved, but also on the surrounding regions of space. When galaxies collide, their interactions create massive shockwaves that can ripple across the cosmic web. These shockwaves can alter the motion of galaxies in nearby clusters and push them toward new regions of the universe. The merger between Andromeda and the Milky Way could, for instance, affect the movements of other galaxies in our local group, including those in the larger Virgo cluster. While the direct impact on these galaxies might not be immediate, the long-term gravitational influence of such a large merger could eventually ripple out across vast distances. This type of cosmic interaction, where one galaxy's gravitational forces influence another's motion, is a common feature of galaxy evolution. In fact, galaxy mergers like the one between Andromeda and the Milky Way are thought to play a crucial role in the growth and evolution of galaxies throughout the universe. As galaxies collide, their stars and gas clouds mix, and their structure can be altered, sometimes leading to the formation of new, more massive galaxies. These mergers are part of the process by which the universe's largest galaxies are born and grow over time. In a sense, the Andromeda-Milky Way collision represents just one of many cosmic events that continually shape the universe. The formation of a new galactic structure. One of the most fascinating outcomes of the collision between Andromeda and the Milky Way is the formation of a new galactic structure. After the merger is complete, the two galaxies will combine to form a single, much larger galaxy. However, this new galaxy will not resemble the familiar spiral shape of the Milky Way or the elliptical shape of Andromeda. Instead, it will likely be an irregular galaxy with a much more chaotic and disordered structure. This irregular shape will come from the merging process itself, as the two galaxies collide, and their stars, gas clouds, and dark matter interact in unpredictable ways. The result will be a galaxy that is far less organized than either Andromeda or the Milky Way. The once distinct spiral arms of the Milky Way will likely become a distant memory, replaced by a more spherical or elliptical shape that will take on a new, more complex form. Interestingly, this new galaxy may not remain static. Just as the Milky Way and Andromeda have been shaped by previous interactions with other galaxies, the merged galaxy will continue to evolve and interact with nearby galaxies in the future. The gravitational forces within the cosmic web will continue to influence the structure and behavior of this new galaxy, ensuring that it will never be completely stable. The future of this merged galaxy will be shaped not only by its own internal dynamics but also by its place within the larger cosmic network. A new era for astronomy, observing the collision in real time. For scientists and astronomers, the Andromeda-Milky Way collision represents an unparalleled opportunity to observe the process of galaxy merging in real time. While previous galaxy mergers have been observed in distant galaxies, none are as close as Andromeda and the Milky Way. This proximity allows astronomers to study the effects of a galactic collision in greater detail than ever before. Over the coming billions of years, astronomers will be able to track the motions of individual stars and gas clouds as they are pulled toward each other by gravity. By observing the collision in real time, we can better understand the forces that govern galaxy evolution and gain deeper insights into the dynamics of galaxy mergers. Scientists also expect to learn more about the role of dark matter in galaxy mergers. Dark matter, the mysterious substance that makes up the majority of a galaxy's mass, is thought to play a critical role in shaping the structure and behavior of galaxies. As the Milky Way and Andromeda merge, the interactions between their dark matter halos will be a key focus of research. By studying how dark matter behaves during a galaxy collision, we may unlock some of the most important secrets about this elusive substance. The end of the Milky Way and Andromeda's identity. As the Andromeda and Milky Way galaxies collide, the individual identities of both galaxies will eventually fade. Over time, the two galaxies will merge completely, and their stars will blend into a new, unified entity. The once distinct spiral arms of the Milky Way will be lost, replaced by a more chaotic, irregular structure. Andromeda's familiar features, such as its massive central bulge and its well-defined spiral arms, will also disappear as the two galaxies become one. This process will take billions of years, but when it's complete, there will be no trace of the Milky Way or Andromeda as we know them today. The stars and planets that once made up these two galaxies will be spread throughout the new galaxy, their identities merging into the vast expanse of space. For those of us living in the Milky Way, this will mark the end of an era. The familiar star systems and constellations that we've come to know will no longer exist in the same form. Yet, as humanity continues to evolve and explore the universe, we may come to think of this moment not as an end, but as the beginning of a new chapter in the story of the cosmos. The fate of Earth, how will we fare? As we continue to look into the future of the Andromeda Milky Way collision, it's important to consider one of the most fundamental questions: what will happen to Earth? With all the gravitational forces at play, the destruction of our planet seems like a real possibility. However, this is not the most likely outcome. As mentioned before, the stars within galaxies are spaced so far apart that even during a galaxy merger, the actual collision between stars is rare. While the gravitational forces at play will certainly have an effect on the structure of the Milky Way and the solar system's position within it, the likelihood of Earth being destroyed by the collision itself is quite low. That being said, the longer-term effects on Earth's environment could be more significant. The shifting of the solar system's position within the galaxy could expose Earth to new cosmic hazards, such as increased radiation from nearby stars or even the possibility of our solar system being ejected from the galaxy entirely. If our solar system is pushed farther from the Sun, Earth's climate could become more hostile to life, leading to changes in the planet's habitability. Yet, even in this scenario, life on Earth may continue to thrive, at least for a while, especially if humanity has made significant advancements in space travel and technology. It's possible that in the distant future, humans could escape the effects of the galactic collision by traveling to other parts of the galaxy, or even other galaxies. If this happens, the human race may be able to survive and adapt to the changing cosmic environment, ensuring that life, in some form, continues long after the Andromeda Milky Way merger. A cosmic legacy. The story of our universe's evolution. The collision between Andromeda and the Milky Way serves as a reminder of the dynamic, ever-changing nature of the universe. Far from being a static and unchanging place, the cosmos is in a constant state of flux, with galaxies, stars, and planets evolving and interacting in complex ways. The Andromeda Milky Way collision is just one of many cosmic events that have shaped the universe and will continue to do so for billions of years to come. As we look to the future, it's important to recognize that while we may not be around to witness the full effects of this galactic merger, the story of the universe will continue long after our time. The collision will create new stars, new galaxies, and perhaps even new forms of life. It will reshape the very fabric of the cosmos, leaving behind a legacy that will be studied and explored by future generations of astronomers, scientists, and perhaps even descendants of humanity who have ventured into the stars. The Andromeda Milky Way collision is a profound reminder that the universe is constantly evolving. While our place in it may seem small, we are part of something far larger and more interconnected than we can fully comprehend. The future of the universe is a vast, uncharted mystery, but one thing is certain: the Andromeda Milky Way collision will be a defining moment in the history of the cosmos. As we move deeper into understanding the future of this galactic collision, it's crucial to explore the timeline of events leading up to and following the merger. While the Andromeda Milky Way collision may seem like an event so distant that it's hard to imagine, the truth is, this cosmic dance is already underway. The collision isn't just a theoretical concept, it's happening right now, though the changes we'll observe are incredibly slow. The beginning of the collision, when will it happen? The actual collision between the Milky Way and Andromeda is still several billion years away, but the process has already begun. Currently, the two galaxies are on a collision course, slowly moving toward one another at a speed of about 110 kilometers per second, approximately 250,000 miles per hour. While this might sound fast, in cosmic terms, it's a relatively slow process. The two galaxies are still roughly 2.5 million light-years apart, which means that even though the collision is inevitable, it will take a long time to actually unfold. Over the next few billion years, the galaxies will slowly drift closer together. The gravitational forces between them will begin to distort the shape of both galaxies. Eventually, they will start to interact with one another, with their gas clouds and stars moving in strange new orbits. The first phase of this collision will involve the galaxies passing through each other, not in a direct crash but more like two colossal clouds of stars and gas merging and overlapping. This will be a chaotic period, with stars flying through each other in vast, nearly empty space. But as the gravitational forces increase, the galaxies will begin to lose their individual identities, their structures becoming more tangled. This gradual merging process will take billions of years, but the eventual result will be the formation of a new galaxy, one that will be far larger and more massive than either the Milky Way or Andromeda. The first collision, a dance of stars. The first direct collision between the Milky Way and Andromeda will not be as catastrophic as you might imagine. Despite the vast number of stars involved in the collision, the distances between stars are so immense that a direct impact between them is highly unlikely. Instead, the two galaxies will pass through each other, their gravitational fields bending the paths of stars and gas clouds. As these two galactic giants collide, the gas clouds within both galaxies will interact in dramatic ways. The collision of gas clouds will trigger massive bursts of star formation, as the gas gets compressed and heated by the intense gravitational forces. This process is known as a starburst event. The rate of star formation during this phase could be significantly higher than what we observe in galaxies today. As new stars are born from the merger, supernovae will occur more frequently, further enriching the galaxies with heavy elements and creating spectacular displays of light. While the individual stars within each galaxy may avoid direct collisions, the gas and dust clouds will create massive, violent bursts of energy as they interact. These interactions will likely lead to the formation of a large number of new stars, but some older stars, especially those in the outer regions of each galaxy, may be flung into new orbits, or even ejected from the galaxies entirely. The movement of stars will drastically reshape the structure of both galaxies, which will become more elliptical over time as their spiral arms fade away. The final merger, a new galaxy takes shape. As the two galaxies move through each other, they will eventually begin to settle into a more stable, final configuration. The forces at play during this merger will gradually force the stars, gas, and dark matter into a new, more cohesive shape. The spiral arms that characterize the Milky Way will eventually be replaced by a massive, irregular galaxy, likely an elliptical galaxy or a lenticular galaxy. These galaxies are more spherical in shape, with a central bulge and less defined spiral arms. During the final stages of the merger, the gas and stars will finally come together, and the two galaxies will form a unified structure. The formation of a new supermassive black hole is expected to occur at the center of the new galaxy as the black holes of the two original galaxies merge. The energy released during this process could trigger the release of massive amounts of radiation, influencing the star formation process and the behavior of surrounding material. At this point, the stars from the two original galaxies will no longer be able to trace their origins back to either the Milky Way or Andromeda. The once recognizable spiral structures will be gone, and the stars will be scattered throughout the newly formed galaxy, their identities lost to time. This new galaxy will be far larger and more massive than either the Milky Way or Andromeda, a true cosmic giant with millions of stars and a far-reaching gravitational influence. The impact on our solar system, a future in flux. Although the fate of the Milky Way and Andromeda will result in a dramatic shift in the structure of the universe, the most pertinent question remains: what will happen to our solar system? Will Earth survive this chaotic process? While it's difficult to predict exactly what will occur, the odds are that our solar system will undergo some significant changes. While the stars themselves may not collide, the gravitational forces exerted during the merger will undoubtedly alter the trajectory of the Sun and its planets. As the galaxies pass through each other, the Milky Way will be subjected to gravitational forces from Andromeda that could move the solar system to a different location within the galaxy. This could push the Sun and its planets closer to the galactic center, or alternatively, farther out into the outer regions of the new galaxy. Such changes could drastically alter the conditions on Earth, potentially affecting its habitability. Furthermore, if the solar system is pushed into a more dangerous part of the galaxy, it could be exposed to a higher rate of cosmic radiation from nearby supernovae or active regions of space. The effects of this radiation on Earth's atmosphere could be significant, leading to possible shifts in climate, weather patterns, and the long-term survival of life on Earth. While the chances of Earth being directly impacted by a collision with another star are small, the environmental changes resulting from a shift in the solar system's position within the galaxy are still worth considering. The final phase of the merger will also likely result in the reorganization of the solar system's orbital dynamics. The gravitational interactions between our solar system and the newly formed galaxy may cause slight changes to the orbits of the planets, although these changes are unlikely to be catastrophic. However, over the course of billions of years, these shifts could cause the planets to experience varying levels of solar radiation, altering their climates and possibly leading to long-term changes in their ability to support life. Surviving the galactic collision, a new hope for humanity? As the Milky Way and Andromeda merge and the structure of the universe is forever altered, what does this mean for humanity? While it's unlikely that humans will be around to witness the collision directly, the eventual formation of a new galaxy presents a fascinating possibility for the future of humanity. If civilization survives for billions of years, humans may one day find themselves in a vastly changed cosmic environment. It's possible that, long before the collision is fully completed, humans could develop the technology to leave the Milky Way altogether. Space exploration could reach new heights, with humanity traveling to other star systems, or even other galaxies, to escape the gravitational chaos that accompanies a galactic merger. In this distant future, the possibility of intergalactic travel could become a reality, offering a way to bypass the potential dangers of a galactic collision. Whether humanity would choose to stay in the newly formed galaxy or venture elsewhere would depend on the technologies and knowledge available at the time. In any case, the Andromeda Milky Way collision offers a compelling glimpse into the ever-changing nature of the cosmos. While the immediate effects on Earth may be slow and imperceptible, the long-term consequences of such a collision will have a profound impact on the universe. Whether we survive to witness it or not, this merger will forever shape the future of our galaxy and beyond. As the Andromeda and Milky Way galaxies collide, one of the most intriguing phenomena that will occur is the merging of their supermassive black holes. Each galaxy houses a central supermassive black hole, and as the two galaxies draw closer and their gravitational forces intensify, these black holes will eventually be drawn together in a cosmic dance. The merger of these black holes is expected to release an enormous amount of energy, primarily in the form of gravitational waves. The supermassive black hole merger, a cosmic powerhouse. Supermassive black holes are mysterious and incredibly dense objects that lie at the centers of galaxies, with masses that can be millions or even billions of times greater than that of our Sun. These black holes are not only the centers of their respective galaxies, but also play a significant role in their evolution. The merger of the Andromeda and Milky Way black holes will mark one of the most violent and energetic events in the history of the universe. As these black holes spiral toward one another, they will begin to emit powerful gravitational waves. These waves are ripples in space-time itself, propagating outward at the speed of light. The collision of two supermassive black holes will cause a disturbance in the fabric of spacetime so intense that it could be detected by advanced instruments like LIGO, Laser Interferometer Gravitational Wave Observatory, which can already detect smaller gravitational waves caused by collisions between smaller black holes or neutron stars. However, the waves produced by this merger would be far stronger and more detectable, potentially offering new insights into the nature of black holes and gravity. When the black holes finally collide, they will merge into a single, larger black hole, resulting in an even more massive object. The surrounding gas and dust will be drawn into this newly formed black hole, emitting high-energy radiation and X-rays. This process, known as an active galactic nucleus, AGN, could create a temporary burst of light so intense that it might outshine the rest of the galaxy. This AGN phase could last for millions of years and could be visible across vast distances, illuminating the entire newly formed galaxy in an extraordinary way. Once the merger is complete, the resulting supermassive black hole will reside at the center of the newly formed elliptical galaxy. The gravitational influence of this enormous black hole will shape the orbits of the stars and gas in the galaxy, determining the ultimate structure of the new galaxy. The black hole's mass will also influence the rate of star formation and the behavior of nearby stars, as its immense gravitational pull will be felt across the entire galactic system. The future of our solar system, life in a changing galaxy. While the large-scale cosmic forces driving the collision of the Milky Way and Andromeda may be fascinating, the immediate effects on our solar system are of particular interest to us. Earth, as we know it, is bound to experience a radically different environment as the collision unfolds. As mentioned earlier, the gravitational interactions during the merger could push the solar system to different parts of the galaxy, but the actual physical conditions on Earth will also change over time. The most obvious impact will come from the changes in the overall galactic environment. As the two galaxies begin to merge, the dense gas clouds and starburst activity will alter the cosmic background radiation. While this radiation is generally harmless, the increased radiation from supernovae, active galactic nuclei, and other high-energy processes could increase the risk of radiation exposure for life on Earth. Over billions of years, this could contribute to significant changes in the planet's atmosphere and surface conditions. Furthermore, the collision could lead to the scattering of rogue planets and stellar remnants throughout the galaxy. Our Sun, which is currently a middle-aged star, may eventually undergo its own transformation into a red giant before dying as a white dwarf. The changes in the galactic environment during the collision could alter the trajectories of the planets and their moons, possibly leading to new gravitational interactions or even changes in Earth's orbit. As the Milky Way and Andromeda galaxies merge, there may also be a fundamental shift in the way stars interact with one another. The relative motion of stars within the new galaxy could lead to higher chances of stellar interactions, with some stars coming into close proximity to one another. These close encounters could trigger supernovae, which would release vast amounts of energy, and the birth of new stars, creating a dynamic and constantly evolving environment. The birth of a new galaxy, a new cosmic era. The final result of the Andromeda Milky Way collision will be the formation of a new galaxy, a massive elliptical or lenticular galaxy that will likely become one of the largest and most impressive structures in the local universe. This new galaxy will be far more massive than either the Milky Way or Andromeda, and its size will have profound effects on the cosmic landscape. One of the key consequences of the merger will be the reshaping of the galaxy's structure. While the Milky Way is a spiral galaxy, with well-defined arms and a flat disk structure, the new galaxy will likely be much more rounded and featureless. The elliptical shape will result from the loss of the rotational motion that characterizes a spiral galaxy. The stars, gas, and dust within the galaxy will be redistributed, and the once pristine structure of both galaxies will be entirely transformed. Additionally, the merger will likely cause the formation of many new stars in the aftermath. The high levels of star formation that occur during and immediately after the collision will give rise to a new generation of stars. Some of these stars may be incredibly massive and short-lived, burning out quickly and leaving behind remnants such as neutron stars or black holes. The ongoing processes of star formation and death will continue to shape the new galaxy for billions of years. While the merger itself will ultimately result in a more stable and massive galaxy, the process leading up to it will be filled with chaos, radiation, and cosmic upheaval. As we look ahead to the future of this galactic collision, it becomes clear that our galaxy's fate is tied to the vast, ever-changing nature of the universe. In a sense, the Andromeda Milky Way collision is not just a moment in the distant future but a fundamental part of the ongoing evolution of the cosmos. What will humanity do in the face of cosmic change? Though this galactic collision is billions of years away, one might wonder, what will humanity do in the face of such a dramatic event? The survival of humanity on Earth during this time is far from certain. If we are to survive as a species, we will need to adapt to the changing conditions of our solar system and galaxy. Humanity may need to develop advanced technologies capable of adapting to new environments, including finding ways to protect the planet from increased radiation or even moving to other star systems. As our technology advances, space exploration may open up the possibility of colonizing other planets and moons. The human race may choose to venture beyond the Milky Way, escaping the chaos of the galactic merger and exploring new regions of space. Whether humanity remains in the new galaxy or becomes an intergalactic civilization will depend on the technological and societal advances we make over the coming millennia. The collision between the Milky Way and Andromeda is a reminder of the transient nature of our existence in the universe. We live in a cosmic environment that is constantly changing, with forces beyond our comprehension shaping the future of our galaxy and everything within it. While the fate of our solar system may seem distant and uncertain, the inevitable collision of these two galaxies is an incredible reminder of the vast, interconnected cosmos we inhabit. As we look toward the future, one thing is certain: the collision of the Milky Way and Andromeda will be a defining event in the history of the universe. Whether humanity is there to witness it or not, it will shape the stars we see today and the galaxies we will see in the far-off future. As we continue to contemplate the long-term implications of the Milky Way and Andromeda collision, it's essential to acknowledge how our understanding of space, time, and galactic dynamics may evolve as this event unfolds. In the realm of astrophysics, each cosmic event, no matter how distant, offers the potential to unlock new secrets about the nature of the universe. The collision of two massive galaxies is a rare and monumental event that will give scientists a once-in-a-lifetime opportunity to study the intricate mechanics of galaxy mergers. Understanding galactic mergers, a new frontier in astrophysics. Galactic mergers are not uncommon in the universe, but the sheer scale of the Milky Way-Andromeda collision makes it particularly intriguing. Through the study of smaller galaxy mergers that have occurred in the past, astronomers have been able to observe how such events unfold. However, the merger between the Milky Way and Andromeda is unique not only because of the massive scale but also because we can study its effects in real time, as our galaxy is directly involved. It offers an unparalleled opportunity to understand the processes of galaxy evolution and the role mergers play in shaping the cosmos. A galactic merger like this involves the gravitational interaction of two massive galaxies. As the two galaxies approach each other, their respective gravitational forces pull on each other's stars, gas, and dust. The initial stages of the collision will involve stars and other objects moving on altered paths as they are drawn toward the dense cores of the merging galaxies. Despite this, the stars themselves are so far apart that direct collisions between them will be exceedingly rare. Instead, the most dramatic interactions will occur in the interstellar medium, where clouds of gas and dust collide, triggering intense star formation. One of the fascinating phenomena to emerge from this process is the creation of a starburst galaxy. During a galactic collision, the compression of gas clouds can trigger the formation of new stars at a rate that far exceeds the usual stellar birth rate. This is one of the most dynamic periods in a galaxy's life cycle, as it becomes a hotbed for stellar creation. The newly formed stars will be concentrated in regions known as starburst zones, and their birth will be closely tied to the interaction of the two galaxies' interstellar gas clouds. The influence of dark matter, the invisible hand guiding the collision. Another crucial aspect of the Andromeda-Milky Way collision is the role of dark matter. While the matter that makes up stars, planets, and other visible structures accounts for only about 5% of the universe's total mass, dark matter constitutes about 27% of the universe's mass energy content. Dark matter cannot be seen directly, but its presence is inferred through its gravitational effects on visible matter. It is the mysterious force that holds galaxies together and governs their rotation. In a galaxy collision, dark matter plays a critical role in guiding the overall structure of the merger. When the Milky Way and Andromeda collide, their dark matter halos will also collide and interact, influencing the way the two galaxies ultimately merge. The gravitational effects of dark matter will help determine the ultimate fate of the new galaxy that forms from this collision, including the distribution of stars, gas, and other components. Some models suggest that the collision of dark matter halos could lead to the formation of a more diffuse and less structured galaxy, which would look vastly different from the well-ordered spiral galaxies we are familiar with. The behavior of dark matter during this collision also opens up many unanswered questions in astrophysics. Despite being invisible, dark matter has a profound effect on the movement of galaxies and the overall structure of the universe. Observing how dark matter behaves during the merger of two massive galaxies could provide critical insights into its nature and properties. Some theories even propose that dark matter may be composed of exotic particles that we have yet to detect, and this collision could offer the perfect conditions for unlocking those mysteries. Long-term evolution, the future of our galactic neighborhood. Once the Milky Way and Andromeda have fully merged into a new, more massive elliptical galaxy, the long-term evolution of this new galaxy will be shaped by a variety of factors. The stellar population will continue to evolve, with new stars being born from the dense gas clouds and old stars aging and dying in spectacular supernovae. Over billions of years, this new galaxy will continue to evolve into a stable, more uniform structure, with a possible gradual decline in star formation as the gas needed for new stars becomes more scarce. Interestingly, the new galaxy may eventually become a red and dead galaxy, where star formation slows dramatically and the galaxy's stellar population ages. The transformation into an elliptical galaxy, which is typically a feature of older, more mature galaxies, could mark the end of an era of intense stellar birth. This is in contrast to the vibrant, star-forming disk of a spiral galaxy like the Milky Way. While this transition may seem like the end of an active galactic period, it would be the beginning of a new era of galactic stability. In terms of the broader cosmic landscape, the collision between the Milky Way and Andromeda will also have ripple effects throughout our galactic neighborhood. The local group, the collection of galaxies that includes the Milky Way, Andromeda, and dozens of smaller galaxies, will undergo significant changes as the gravitational influence of the merging galaxies alters the orbits of nearby objects. The Milky Way's gravitational influence will likely change, which could lead to the ejection of smaller galaxies from the local group. In the distant future, this region of space could become an entirely different cosmic environment, shaped by the aftereffects of the galactic collision. The role of humans in this cosmic event. Will we witness the galactic collision? Now many might ask, what role will humans play in all of this? Will we be around to witness the dramatic events of the Milky Way-Andromeda collision? The answer, as it stands, is no. The collision is expected to take place over the course of billions of years, far beyond the lifetime of our species, and even the Earth itself. Our planet's fate is likely tied to the eventual death of the Sun, which will undergo its own transformation into a red giant before eventually shrinking into a white dwarf. However, humanity's survival depends not only on the life cycle of the Sun but on the broader question of our technological capabilities and adaptability to future cosmic changes. While the immediate effects of the galactic merger will be felt long after the human species has evolved or perhaps even disappeared, the knowledge gained from studying this collision may inform the way we approach space exploration. By the time the Andromeda and Milky Way galaxies are on the brink of collision, humanity may have developed technologies capable of enabling the exploration and colonization of other star systems. In this case, the cosmic collision might be a distant memory for those who have long since left Earth, perhaps living on distant exoplanets in other galaxies. A cosmic perspective, understanding our place in the universe. As we consider the future of the Milky Way and Andromeda galaxies, it's important to reflect on the broader significance of this collision in the context of the universe as a whole. The universe itself is in a constant state of flux, with galaxies, stars, and planets forming, evolving, and dying. The collision of two galaxies, while a momentous event, is just one part of the ongoing cosmic cycle that spans eons. It reminds us that our universe is vast, dynamic, and ever-changing, with forces at play far beyond our comprehension. In the grand scheme of things, our place in the universe is fleeting. The collision between the Milky Way and Andromeda is a reminder that our solar system, our galaxy, and even our very existence are part of a much larger, interconnected cosmic tapestry. As we explore the mysteries of space and look to the future, we gain a deeper understanding of our place in the cosmos, a place that is constantly evolving and changing, shaped by the immense forces of the universe. As we look deeper into the vast timeline of the Milky Way-Andromeda collision, it's essential to consider the long-lasting effects that this event will have on our galaxy's structure and its neighboring systems. While many of the details remain uncertain due to the sheer scale and complexity of galaxy mergers, astronomers continue to make strides in their ability to predict and simulate these cosmic occurrences. the long-term effects on star formation, the eventual reshaping of our galaxy's morphology, and the impact on other star systems within the local group will create a fascinating narrative that stretches far into the future. The role of black holes in the galactic collision. One of the most intriguing aspects of the Andromeda Milky Way collision is the role that black holes, both supermassive and stellar, will play in the event. The Milky Way has a supermassive black hole at its center, known as Sagittarius A*, and Andromeda also harbors a similarly massive black hole at its core. As the two galaxies collide, these supermassive black holes will begin to draw closer together due to the intense gravitational forces at play. The eventual fate of these black holes is one of the most exciting and mysterious aspects of the collision. The black holes may spiral inward toward each other, gradually merging into one larger supermassive black hole. This process could release an extraordinary amount of energy, in the form of gravitational waves, which are ripples in spacetime that travel across the universe. These waves are generated by massive objects like black holes and neutron stars as they interact, and their detection provides valuable insight into the workings of these exotic objects. The merger of two supermassive black holes would not only provide a dramatic cosmic event, but also a significant scientific breakthrough, potentially allowing us to understand the mechanics of black hole mergers and the behavior of gravity under extreme conditions. During the merging process, a significant amount of energy could also be released in the form of X-rays and other high-energy radiation, further illuminating the black holes and their surrounding accretion disks, regions of hot gas and dust that spiral toward the black holes before being swallowed. The material in these accretion disks gets heated to incredibly high temperatures, emitting powerful radiation as it approaches the event horizon, the point beyond which not even light can escape the black hole's gravitational pull. The radiation emitted during this merger could illuminate the areas surrounding the black holes, making them some of the brightest objects in the universe during the event. The reign of elliptical galaxies. Following the collision, one of the primary outcomes will be the formation of an elliptical galaxy, a type of galaxy with a smooth, round shape that lacks the distinct spiral arms seen in galaxies like the Milky Way and Andromeda. As the two galaxies merge and their stars, gas, and dark matter mix together, the resulting structure will be vastly different from the orderly spiral disk that we are familiar with. In fact, this process of galactic merger is often a key step in the formation of elliptical galaxies, which are typically formed from the remnants of earlier galaxy collisions. Elliptical galaxies are generally composed of older, redder stars, and they have much less gas and dust than spiral galaxies. This makes them less likely to undergo new star formation, leading to a steady decline in the creation of new stars over time. As a result, the future elliptical galaxy formed by the collision between the Milky Way and Andromeda will eventually become what is known as a red and dead galaxy, where most of the star formation has ceased, and the stars that remain are aging. However, while the stars in the new elliptical galaxy may eventually become less active, the surrounding environment will be a rich laboratory for studying the life cycle of galaxies. The galaxy's central regions will likely be populated by a dense concentration of stars, and supermassive black holes, such as the merged black hole at the center, may continue to grow, influencing the behavior of the galaxy's stellar population. Over billions of years, the elliptical galaxy will continue to evolve, but its transformation into a red and dead galaxy marks the beginning of a new stage in its life cycle, one where the energy output from new stars begins to dwindle and the galaxy settles into a quieter existence. The fate of our solar system and the Earth. At the heart of our fascination with the Milky Way-Andromeda collision lies a crucial question: what will happen to our solar system and planet Earth? Given that the event will take place over billions of years, humanity's immediate survival is not at risk. Our sun will continue to burn for approximately another 5 billion years before it transforms into a red giant, and eventually a white dwarf. However, the cosmic environment surrounding our solar system will undergo significant changes as the collision progresses. As the two galaxies interact, gravitational forces will perturb the orbits of stars, including our own Sunday. These changes in the gravitational field could cause the Sun's orbit within the galaxy to shift, potentially placing it in new regions of the galaxy. While the Sun's orbit will not likely cause it to collide with another star, the gravitational interactions between the two galaxies could create a new, more chaotic environment for our solar system. This disruption could potentially lead to an increase in the number of near-Earth objects, such as asteroids and comets, as their paths are altered by the merging galaxies. Additionally, the collision could have effects on the distribution of interstellar material, such as gas and dust, which may influence the star formation rates in our region of space. The solar system might even be drawn into a new cluster of stars, further shifting the balance of the galactic environment. While none of these changes will likely have an immediate impact on the habitability of Earth, they could create a more turbulent cosmic environment, with increased cosmic radiation or changes in the galactic magnetic field, which could affect the solar wind. A galactic tapestry, merging into the future. Ultimately, the collision between the Milky Way and Andromeda serves as a reminder of the ever-changing, dynamic nature of the universe. Galaxies are not static, but rather, they are living, evolving entities that are constantly interacting with one another. The future merger between our galaxy and Andromeda will mark the end of one chapter in the story of these galaxies and the beginning of another. As we look to the future, we may find that this event, though it seems distant in both space and time, will shape the very structure of the cosmos for billions of years to come. While the collision is still many billions of years away, understanding the processes at work in this cosmic drama helps us to better appreciate the complexity of the universe and the interconnectedness of all things within it. Each galaxy, each star, and each planet is a part of this grand tapestry, and every event, no matter how large or small, contributes to the ongoing evolution of the cosmos. As our understanding of galactic mergers deepens, we are reminded that the universe is an ever-changing place, where no entity is truly permanent, and where each new development opens up new questions and possibilities for exploration. In the grand scheme of things, the collision of the Milky Way and Andromeda is a natural and inevitable process. But it is also a reminder of the beauty of our universe, its constant motion, its ever-evolving nature, and its capacity to surprise us with phenomena that stretch our understanding of space and time. As we continue to explore the mysteries of the universe, we may find ourselves part of an even greater story, one that stretches far beyond our galactic neighborhood and into the depths of the cosmos. As we look further into the long-term future of the Milky Way and Andromeda's collision, it's important to recognize the ripple effects that this galactic merger will have on the surrounding universe. The merging of two massive galaxies will not only create new, massive structures within the local universe but will also serve as an example of the ever-changing and dynamic nature of the cosmos itself. As we consider the immense scale of the event and the years of observation that will follow it, we also have to acknowledge the broader cosmic implications that these galactic mergers may carry. The broader implications for the local group and neighboring galaxies. The Milky Way and Andromeda are not solitary entities in the universe. They belong to a group of galaxies known as the local group, which includes several smaller galaxies, such as the Triangulum Galaxy and a number of dwarf galaxies that are gravitationally bound to the Milky Way and Andromeda. As the two largest galaxies in the group collide and merge, they will affect the gravitational dynamics of their companions in profound ways. For instance, the Triangulum Galaxy, which is another spiral galaxy in the local group, could be affected by the collision. It's possible that during the merger, Triangulum could either be absorbed into the newly formed galaxy or be ejected out into the broader universe, depending on the specific gravitational forces at play. The dwarf galaxies in the local group, which are far less massive, will also experience some level of disruption, with their stars and gas being pulled into the center of the merging system or dispersed into the surrounding void. The local group itself may undergo a significant transformation, with a rearrangement of its galaxies and a reshuffling of its structures. Some of the smaller galaxies could be absorbed into the larger newly formed elliptical galaxy, while others may be cast out, their stars scattered across intergalactic space. Over time, the entire local group could become more tightly bound, or, conversely, it could break apart, sending its galaxies out into the vast emptiness of the universe. This broader effect is not unique to our region of space. Galaxies and galaxy groups across the universe are engaged in similar processes. The collision of galaxies is not an isolated event, but part of a grander cycle of cosmic evolution that stretches across the entire universe. Every galaxy, no matter how small, is influenced by the larger galactic networks in which they exist, and the future of the Milky Way and Andromeda collision will contribute to the ongoing reshaping of the entire universe. Dark matter and its role in the collision. While much of the attention surrounding the Milky Way-Andromeda collision focuses on the visible matter, the stars, gas, and dust, there's another, less tangible component that plays a critical role in shaping the outcome of this galactic merger: dark matter. This mysterious substance makes up about 85% of the mass of the universe, and although it does not emit light or energy, it has a gravitational influence that affects the motion of galaxies and other large structures. Dark matter exists in large halos around galaxies, and these halos will interact when the Milky Way and Andromeda collide. The gravitational effects of dark matter are expected to play a crucial role in shaping the dynamics of the collision, particularly as the two galaxies merge. As the galaxies draw closer together, their dark matter halos will begin to interact, merging and reshaping the gravitational landscape of the galaxies. This will influence the orbits of stars, gas, and other matter within the galaxies, potentially changing their paths and even disrupting their ability to form new stars. Dark matter also plays a role in the overall shape and stability of galaxies. The dark matter halo helps to maintain the structural integrity of a galaxy, preventing it from flying apart due to the centrifugal forces generated by the motion of its stars. During the collision, the interaction of dark matter halos will help to stabilize the newly formed elliptical galaxy, ensuring that it doesn't disintegrate despite the violent forces at play. The mystery of dark matter remains one of the most tantalizing puzzles in modern astrophysics. While its influence is well documented, scientists are still unsure about its exact nature. Is it composed of exotic particles that interact with ordinary matter only through gravity, or is it made of something else entirely? As the Milky Way and Andromeda collide, researchers hope that the gravitational interactions between their dark matter halos may provide new insights into the nature of this elusive substance. It's possible that the collision could offer new clues about dark matter's role in the formation and evolution of galaxies, shedding light on one of the most profound mysteries in science: the influence on the cosmic microwave background. The collision between the Milky Way and Andromeda is a dramatic event that will reshape the structure of our galactic neighborhood, but it will also have a subtle influence on the broader universe. One of the most enduring remnants of the Big Bang is the cosmic microwave background (CMB), the faint glow of radiation left over from the early universe. This radiation provides a snapshot of the universe when it was just 380,000 years old, and its study has provided scientists with valuable information about the early conditions of the universe. While the collision between the Milky Way and Andromeda will not directly alter the CMB itself, the long-term gravitational effects of this galactic merger will influence the large-scale structure of the universe, including the distribution of galaxies and clusters of galaxies. As galaxies collide and merge, they move through the cosmic landscape, affecting the distribution of matter on the largest scales. This can subtly influence the way that the CMB appears, as the large-scale structure of the universe affects the way that light and radiation propagate through space. The Milky Way-Andromeda collision will likely contribute to a shift in the cosmic web, the vast network of galaxies, galaxy clusters, and voids that stretches across the universe. The cosmic web is shaped by the gravitational pull of galaxies and dark matter, and as our galaxy and Andromeda merge, they will contribute to the growth and evolution of this web. The event will be another piece in the larger puzzle of cosmic evolution, adding to our understanding of how the universe has expanded and evolved over the past 13.8 billion years. The timeline of the collision, a slow and steady progression. One of the most fascinating aspects of the Milky Way-Andromeda collision is the incredibly long timescale over which it will occur. While the event itself is still billions of years away, the process of the galaxies merging will take several billion years to complete. This means that the cosmic landscape we see today will change gradually over an immense period of time. For us, humans who live in a world defined by the short span of our lifetimes, the timeline of galactic collisions can seem unfathomably slow. In the earliest stages of the collision, the two galaxies will begin to approach one another, their mutual gravitational attraction slowly drawing them closer together. As the galaxies collide, the process of star formation will begin, and new stars will be born from the compressed gas and dust within the galaxies. Over the course of billions of years, the two galaxies will pass through multiple phases of interaction, with their stars being drawn into complex orbits, and their gas clouds being disturbed. Eventually, after several billion years of collision and interaction, the two galaxies will settle into a single, elliptical galaxy. During this time, many of the stars in both galaxies will have long since finished their life cycles, and new star formation will have slowed down significantly. The central black holes of both galaxies will merge into one larger supermassive black hole, and the newly formed elliptical galaxy will begin to evolve into a red and dead system, where star formation is a rare event. The collision between the Milky Way and Andromeda is not just an isolated cosmic event. It is part of the broader story of galaxy evolution, a process that stretches across billions of years. It will reshape our understanding of how galaxies interact, how they evolve, and how the universe itself is slowly changing. As we continue to unravel the complexities of the Milky Way-Andromeda collision, it's fascinating to look at the nature of the interactions between these two massive galaxies on a more granular level. To truly understand what will happen during this collision, we must explore the interactions of stars, gas clouds, and the supermassive black holes at the centers of each galaxy. These components will play critical roles in shaping the final outcome of the collision, and their dynamics will be essential in understanding the transformation of both galaxies and their surrounding environments. The star interactions during the collision. At first glance, it might seem that a galactic collision would be a catastrophic event for the stars within each galaxy. After all, these galaxies are packed with stars, gas clouds, and cosmic dust, all of which could collide violently. However, in reality, the vast distances between individual stars mean that most stars will pass through one another without directly colliding. The chance of two stars actually crashing into each other during the collision is extremely low due to the immense empty space between them. Instead, what will occur is that the gravitational forces between the two galaxies will pull stars into altered orbits. As the galaxies approach each other, the gravitational pull from Andromeda will cause stars in the Milky Way to shift their orbits, and vice versa. This will lead to some dramatic changes in the structure and distribution of stars within both galaxies. Some stars will be flung outward, potentially becoming part of the intergalactic medium, while others may be drawn toward the centers of the galaxies. However, the most important event related to star interactions will likely be the formation of new stars. As the two galaxies collide, their gas clouds, composed of hydrogen, helium, and other elements, will be compressed by the immense gravitational forces. This compression will trigger massive bursts of star formation. New stars will be born from these compressed gas clouds, lighting up the surrounding regions with their intense radiation. This new wave of star formation will likely lead to the creation of a new generation of stars that could drastically alter the overall population of stars in both galaxies. These stars will have different characteristics from the existing stars, potentially adding more blue stars, young, hot stars, to the mix, as well as creating new star clusters. The role of gas and dust clouds in the collision. The gas and dust clouds within each galaxy are crucial in shaping the dynamics of the collision. These clouds are primarily made up of hydrogen gas, which is the raw material for star formation. When two galaxies collide, their interstellar gas clouds will begin to interact, leading to shock waves and massive compression. This compression will trigger the formation of new stars, as well as influence the ongoing star formation rate within both galaxies. As the Milky Way and Andromeda collide, these clouds of gas will also have an effect on the motion of stars. The immense pressure from these gas clouds could cause a redistribution of stellar material across both galaxies. Some stars will be sent spiraling into the galaxy centers, where they will interact with the supermassive black holes, while others may be expelled into the surrounding space, potentially becoming part of the intergalactic medium. The gas clouds themselves will also undergo dramatic changes during the collision. The intense forces will cause some of the gas to be funneled into the centers of the galaxies, where it will fuel the supermassive black holes. This could lead to an increase in the activity of these black holes, resulting in intense outflows of energy in the form of radiation and particles. These outflows, called active galactic nuclei, AGN, can significantly alter the environment of both galaxies. The supermassive black holes at the heart of the collision. Perhaps the most fascinating and mysterious aspect of the Milky Way-Andromeda collision is the eventual merging of their supermassive black holes. Both the Milky Way and Andromeda contain incredibly massive black holes at their centers, with masses on the order of millions to billions of times the mass of the Sun. These supermassive black holes play a key role in the structure and behavior of their respective galaxies. As the two galaxies approach each other, and eventually collide, their supermassive black holes will also begin to interact. The gravitational forces from the surrounding stars and gas will cause these black holes to drift closer together, eventually leading to a merger. This process is expected to release an enormous amount of energy, primarily in the form of gravitational waves, ripples in space-time caused by the acceleration of massive objects. Gravitational waves have been detected by observatories on Earth, but the merger of two supermassive black holes will produce waves that are far more intense and detectable across much greater distances. The merger will also likely result in the formation of an even larger supermassive black hole at the center of the new galaxy, which will have a profound effect on the dynamics of the surrounding stars, gas, and dust. The newly formed black hole could also generate powerful jets of material, further altering the environment of the new galaxy. In the long run, the merged black hole will likely become more quiescent, but it will continue to influence the surrounding galaxy, pulling in gas and stars from the outskirts and reshaping the dynamics of the newly formed galaxy. This process, however, will take billions of years to complete, and the full effects of the black hole merger won't be fully understood for eons. The fate of our solar system. A key question that many people have when thinking about the Milky Way-Andromeda collision is the fate of our solar system. Will the Earth survive the cosmic chaos, or will our home be destroyed in the process? While it's impossible to predict every aspect of the collision with absolute certainty, we can make some educated guesses based on our understanding of galactic dynamics. As previously mentioned, the actual likelihood of our solar system colliding with another star during the galactic merger is extremely low. The distances between stars are vast, and even though the gravitational forces between the two galaxies will alter the orbits of many stars, the chances of a direct collision between stars in our solar neighborhood are negligible. Instead, the most significant impact on our solar system will likely come from the overall reshaping of the galaxy. The collision will change the structure of the Milky Way, potentially moving our solar system to a different position within the new galaxy. While it's impossible to say for certain where our solar system will end up, it's likely that we will be relocated to a new region of the galaxy, potentially moving from the outer spiral arms to a more central location. This could bring us closer to the center of the galaxy, where the environment is much more dynamic and chaotic. The changes in the galactic environment could have several long-term effects on our solar system. For instance, the increase in star formation could mean that our solar system would pass through regions of space that are home to newly born stars. These areas could be rich in interstellar radiation, which could have an impact on the Earth and the conditions that support life. The increase in radiation might lead to changes in the Earth's atmosphere or alter the space weather that we experience. In addition, the movement of stars in the new galaxy could cause an increase in gravitational interactions with nearby stars. This might lead to more frequent encounters with rogue planets or other star systems, which could destabilize the orbits of planets and potentially send objects from the Oort cloud or Kuiper belt toward the inner solar system. Even though the chances of these dramatic events occurring are low, it's possible that they could have significant effects on the future of our planet. Over billions of years, these interactions could trigger new evolutionary paths for life on Earth, or, in the most extreme cases, could potentially threaten the survival of life. The long-term outlook for the universe. The Milky Way-Andromeda collision will be one of the most transformative events in the history of our galactic neighborhood. However, it is not an isolated occurrence. The universe is in a constant state of flux, with galaxies colliding and merging on vast timescales. The Milky Way's eventual collision with Andromeda is part of a broader pattern of galactic evolution that is happening across the universe. In the far future, the newly formed elliptical galaxy created by the merger of the Milky Way and Andromeda will continue to evolve. The universe itself will keep expanding, and over time, other galaxies will begin to collide and merge. Eventually, the expansion of the universe could lead to the separation of distant galaxy clusters and the isolation of our cosmic region. These future events will continue to shape the structure and evolution of the universe, even as the merger of the Milky Way and Andromeda takes its place in the grand cosmic timeline. This collision may be one of the last major events that our region of the universe will experience before the universe itself enters a new phase of existence. Whether through the gravitational interactions of galaxies, the birth and death of stars, or the merging of supermassive black holes, the universe will continue to evolve, forever shaped by the ongoing processes of galactic collision and cosmic evolution. As we continue to reflect on the future collision of the Milky Way and Andromeda, it becomes clear that while this cosmic event is both awe-inspiring and intimidating, it is ultimately just a small chapter in the broader, ever-evolving story of the universe. The merger of our two galaxies will undoubtedly reshape the very structure of the cosmos, but the aftermath of this collision will continue to unfold over billions of years, with countless other galactic events likely to take place long after the dust settles. The role of dark matter in the collision. One of the most intriguing aspects of the Milky Way-Andromeda collision is the role that dark matter will play. Dark matter, which is thought to make up about 85% of the mass in the universe, is a mysterious and invisible substance that cannot be detected directly by telescopes. However, its gravitational effects on visible matter give us important clues about its existence and influence. Dark matter does not emit light or radiation, and it doesn't interact with regular matter in a way that we can easily observe. Nevertheless, it affects the motion of galaxies and their internal structures. During the collision of the Milky Way and Andromeda, dark matter will exert a significant influence on how the galaxies interact. As both galaxies move toward each other, their dark matter halos, vast regions surrounding the galaxies composed of dark matter, will begin to merge. This dark matter collision will be nearly invisible to us, but its effects will be profound. As dark matter interacts, it will influence the behavior of stars, gas, and other visible matter in the galaxies, potentially helping to determine how the final structure of the merged galaxy will look. In addition to influencing the dynamics of the collision, dark matter is also thought to play a role in the formation of galactic structures. The distribution of dark matter may help to shape the final elliptical galaxy that emerges from the merger, potentially influencing the formation of spiral arms or the overall distribution of stars and gas. Dark matter's elusive nature continues to baffle scientists, but its role in galactic mergers is a key component of understanding how these events unfold. The future of life in our solar system. Given the potential upheaval caused by the Milky Way-Andromeda collision, many have wondered what this event will mean for life on Earth. While it's true that the collision itself will not directly destroy our planet, it will have far-reaching effects on our solar system and its position in the galaxy. The effects on life, however, are less straightforward to predict. Life on Earth, as we know it, has evolved under relatively stable conditions, but these conditions are tied to the position of our solar system within the Milky Way. As the collision progresses, our solar system will likely experience a shift in its position within the galaxy. This could bring us closer to the galactic center, where the environment is much more chaotic, or further out into more sparsely populated regions of the galaxy. These changes could alter the amount of radiation we receive from the galactic core or introduce new threats in the form of nearby stars and cosmic events. While the direct consequences of these changes on life on Earth may be hard to predict, the long-term survival of life on our planet will be increasingly dependent on how we adapt to the new conditions. Our solar system will also experience shifts in the positions of planets, asteroids, and other objects in our neighborhood, which could affect the conditions on Earth. In the most extreme cases, increased radiation or gravitational interactions with other stars could make life more difficult or even threaten our planet's habitability. However, given the vast timescales involved, it is also possible that life on Earth could adapt to these changes, evolving in ways that we cannot currently foresee. Galactic mergers and the evolution of the universe. The merger of the Milky Way and Andromeda is not an isolated event. It represents part of a broader pattern of galactic evolution that is taking place throughout the universe. Galaxies are constantly interacting with one another, and as the universe continues to expand, more and more collisions and mergers will occur. These events shape the structure of the universe, creating new galaxies, stars, and even black holes in the process. In the distant future, our galaxy and Andromeda will become part of a much larger galaxy. This galaxy will continue to evolve, potentially absorbing other smaller galaxies as the universe expands. While it is impossible to know exactly what the final outcome of these mergers will look like, it is clear that they will contribute to the overall evolution of the universe. Galactic mergers can have a profound effect on the star formation rate and the distribution of matter throughout the universe. When galaxies collide, they often trigger bursts of star formation, leading to the birth of new stars and the creation of new structures within the galaxy. These mergers also create supermassive black holes, which play a key role in the dynamics of galaxies and the surrounding space. The eventual fate of these black holes, including the possibility of them merging with others to form even larger black holes, will continue to shape the evolution of the cosmos. As the universe continues to expand and galaxies continue to collide, the Milky Way-Andromeda merger will be remembered as one of the most significant events in the history of our cosmic neighborhood. However, it is far from the last. The universe will continue to evolve, and new mysteries will arise as we attempt to understand the vast, interconnected web of galaxies and cosmic forces. The impact of the collision on our understanding of the universe. The collision between the Milky Way and Andromeda is not just a fascinating event in the history of our galaxy. It is also a key moment for scientists to study the dynamics of galactic mergers and the larger processes that govern the universe. The insights gained from studying the collision will provide valuable information about the formation and evolution of galaxies, the behavior of dark matter, and the role of supermassive black holes in shaping the structure of the cosmos. By observing the Milky Way-Andromeda collision, astronomers can gain a deeper understanding of how galaxies interact and evolve. This knowledge can be applied to other galactic mergers happening throughout the universe, helping scientists to predict the outcomes of future collisions and learn more about the long-term evolution of galaxies. The collision also offers a unique opportunity to study the behavior of stars, gas clouds, and dark matter under extreme conditions, giving us a glimpse into the processes that shape the universe. The insights gained from this cosmic event will help to answer some of the most profound questions in astrophysics and cosmology. For instance, scientists will be able to learn more about the origins of supermassive black holes and how they form at the centers of galaxies. The merger will also provide clues about the distribution of dark matter in galaxies and how this invisible substance influences galactic dynamics. In the long run, this research will help us to better understand the forces that govern the universe, giving us a deeper appreciation of the complexities of space and time. A cosmic event in the context of eternity. As we contemplate the collision between the Milky Way and Andromeda, it's important to remember that this is just one of many such events that have occurred, and will continue to occur, in the vast stretch of cosmic time. The universe is in a constant state of change, with galaxies forming, colliding, and evolving over billions of years. The Milky Way-Andromeda collision is merely the next chapter in an ongoing story that will continue long after humanity is gone. The future of our solar system, our galaxy, and the universe as a whole is bound to be shaped by these cosmic events. And while we may be mere spectators in this grand drama, our understanding of the universe allows us to appreciate the scale and significance of these events. The collision of the Milky Way and Andromeda is a reminder that the universe is a dynamic and ever-changing place, full of mysteries waiting to be discovered. As we continue to explore the impending collision between the Milky Way and Andromeda, it's crucial to consider the broader implications that this event has on our understanding of cosmic time and space. These galactic interactions, while incredibly dramatic on a cosmic scale, are just part of a much larger story about the universe's evolution. Galactic mergers like the one between the Milky Way and Andromeda are not just local phenomena, they have implications for the entire universe, influencing its structure and the behavior of stars, gas, and even dark matter on an unprecedented scale. How galaxies merge. A look into cosmic dynamics. Understanding how galaxies merge and the forces at play requires us to dive into some fundamental aspects of physics and astronomy. The primary force that drives the collision of galaxies is gravity. Galaxies, like any other objects in space, are governed by the laws of gravity. The gravity of the stars, gas clouds, and dark matter in each galaxy will pull them toward one another as the galaxies get closer over time. During the collision, the stars themselves will mostly pass by each other without colliding. The distances between stars in a galaxy are vast, so even though the galaxies will interact strongly, individual stars are unlikely to collide. Instead, it is the gravitational pull between the two galaxies that will cause significant disruptions. As the two galaxies interact, their gas clouds will collide, leading to bursts of star formation. This process is known as a starburst, and it is one of the most remarkable phenomena that can occur during a galactic merger. The gravitational forces between the galaxies will also cause them to warp and stretch, forming long tidal tails of stars and gas that stretch out into space. These tidal tails are remnants of the galaxies being pulled and deformed by the immense gravitational forces at play. Over time, the merger will lead to the eventual coalescence of the two galaxies into a new, larger galaxy. This new galaxy will likely be an elliptical galaxy, a type of galaxy that has a more rounded, smooth shape compared to the spiral structure of the Milky Way and Andromeda. The role of supermassive black holes. One of the most exciting and mysterious aspects of the Milky Way-Andromeda collision is the interaction of the supermassive black holes at the centers of both galaxies. Both the Milky Way and Andromeda are home to supermassive black holes that are millions to billions of times more massive than our Sun. These black holes are not just at the center of their respective galaxies. They are key players in shaping the structure and dynamics of the entire galaxy. As the two galaxies collide, their supermassive black holes will eventually draw closer to one another, and when they do, the gravitational forces will begin to have a profound effect. The process of two supermassive black holes merging is known as a black hole merger, and it is one of the most violent and energetic events in the universe. When these black holes collide, they will release enormous amounts of energy in the form of gravitational waves, ripples in spacetime that spread out across the universe. Gravitational waves were first predicted by Albert Einstein as part of his theory of general relativity, and they were directly detected for the first time in 2015 by the Laser Interferometer Gravitational Wave Observatory, LIGO. The merger of supermassive black holes in a galactic collision is expected to produce some of the most intense gravitational waves ever detected, potentially allowing us to learn even more about the nature of black holes and the fundamental properties of spacetime itself. The merging of the supermassive black holes will likely lead to the formation of an even larger black hole at the center of the newly formed galaxy. This new supermassive black hole will be a dominant force in the galaxy, influencing the orbits of nearby stars and possibly even triggering the formation of new stars in the surrounding regions. Star formation and stellar evolution during the collision. One of the most fascinating consequences of a galactic merger is the dramatic increase in star formation that often occurs as a result of the collision. As the gas clouds in the two galaxies collide and compress, they create conditions that are ideal for new stars to form. This burst of star formation, known as a starburst event, can lead to the creation of thousands or even millions of new stars within a relatively short period of time. During the merger of the Milky Way and Andromeda, the compression of gas clouds will likely trigger numerous starburst events across both galaxies. These new stars will include both young, massive stars and smaller, less luminous stars. The birth of massive stars, in particular, can lead to the creation of supernovae, explosive deaths of stars that release an enormous amount of energy. Supernovae can also trigger the formation of new elements and enrich the interstellar medium with heavier elements, further influencing the evolution of the new galaxy. The intense star formation during the merger will also have an impact on the overall structure of the galaxy. As new stars are born, the surrounding gas and dust will begin to organize into regions of high stellar density. These areas will become the new hubs for star formation, and the new galaxy will slowly begin to take shape as a more chaotic, star-packed system. Eventually, as the merger progresses and the stars and gas settle into their new orbits, the new galaxy will take on a more stable form, likely an elliptical galaxy with a smooth, featureless appearance. The potential for new planets and solar systems. While the Milky Way and Andromeda are composed of countless stars, the creation of new stars during the merger also presents the possibility for new planetary systems to form. When stars are born in dense regions of gas and dust, they often bring with them the potential for planets to form as well. These planets would orbit the new stars and could potentially harbor life, depending on their distance from their parent star and the conditions in their atmosphere. If our solar system survives the initial stages of the collision, it is possible that, over billions of years, new planets could form in the merged galaxy. These planets may not necessarily be like Earth, but they could possess the right conditions for life to arise, especially if they are located in the habitable zone of their stars, where liquid water could exist. The idea of life flourishing on new planets within the merged galaxy is a tantalizing possibility, but it remains speculative at this point. Nonetheless, it underscores the potential for new opportunities for life in the universe, even in the aftermath of a galactic collision. The long-term future of the universe. The collision between the Milky Way and Andromeda will mark a significant moment in the long-term future of the universe, but it is by no means the final chapter. Galactic mergers are a natural part of the cosmic cycle, and as the universe continues to expand and evolve, more mergers and collisions will occur. These events shape the distribution of matter and energy across the cosmos, influencing the formation of new stars, galaxies, and even black holes. As the Milky Way and Andromeda merge, the new galaxy will eventually become a stable, mature system. Over time, it will likely become part of an even larger structure, possibly merging with other galaxies in the future. However, even this future is not set in stone. As the universe continues to expand, galaxies will continue to interact and evolve, and the fate of our galaxy, along with the fate of the entire universe, remains an open question. In billions of years, the energy from stars will begin to dissipate as they burn out, leaving behind a colder, darker universe. Eventually, stars will cease to form, and the galaxies will become increasingly isolated. The universe will continue to expand, but its future is uncertain, perhaps leading to an eventual heat death, where all matter is spread so thin that the universe becomes a vast, empty expanse. While we may not be around to witness the final moments of the universe's evolution, the collision of the Milky Way and Andromeda serves as a reminder of the immense scale of time and space. It's a small piece of the puzzle in the grand narrative of the cosmos, but it is an important moment nonetheless, a cosmic event that will shape the future of the universe for billions of years to come. As the future of the Milky Way and Andromeda unfolds, it's essential to understand the broader context in which these events are taking place. The collision between two galaxies is not just a one-time event but part of the ongoing cosmic dance that has shaped the universe as we know it. In a sense, the merger between our galaxy and Andromeda is both a beginning and an end, ushering in a new era for both galaxies, while also signaling the inevitable death of their previous forms. But what will this mean for the surrounding cosmic environment, and how will it influence the larger structure of the universe? Galactic mergers and the evolution of the universe. Galactic mergers are not unique to the Milky Way and Andromeda. In fact, they are an integral part of the life cycle of galaxies. Over the course of billions of years, galaxies will collide, merge, and evolve in a series of complex interactions. This is how the universe grows and changes over time, with galaxies coming together to form larger and more complex systems. The merger between the Milky Way and Andromeda will serve as a major milestone in this ongoing process of galactic evolution. Galaxies are constantly interacting with one another, drawn together by gravity, forming what are known as galactic clusters. These clusters are massive groupings of galaxies, sometimes containing thousands of individual galaxies, all bound together by their mutual gravitational pull. While the Milky Way and Andromeda are on a collision course, they are not the only two galaxies in the region. There are many other galaxies in our local group, such as the Triangulum Galaxy, which will also be affected by the interaction between the Milky Way and Andromeda. The entire local group of galaxies is in a state of constant motion, with galaxies continually being pulled toward each other by the force of gravity. In the larger scheme of things, galactic mergers are a vital process for the evolution of the universe. As galaxies collide and merge, the gravitational forces at play reshape the distribution of matter and energy in the cosmos. These mergers lead to the creation of new stars, new planets, and even new black holes. Over billions of years, galactic mergers have contributed to the formation of the largest structures in the universe, such as galaxy clusters and superclusters. These structures are the building blocks of the cosmos, influencing the flow of matter and energy on an enormous scale. The fate of the solar system: will we survive? One of the most pressing questions surrounding the Milky Way-Andromeda collision is the fate of our solar system. As the two galaxies draw closer, our solar system will inevitably be affected by the changes occurring in the galactic environment. However, while the overall structure of our galaxy will be dramatically altered, the fate of our solar system remains uncertain. So, what can we expect? First, it's important to note that the vast distances between stars in our galaxy mean that the chances of our Sun colliding with another star are extremely low. In fact, even as the two galaxies pass through each other, the stars within them will mostly pass by each other without direct interaction. However, the gravitational forces generated by the merger will have other effects on our solar system. The gravitational influence of Andromeda and the Milky Way will change the orbits of stars and potentially even our entire solar system. In the early stages of the merger, the Milky Way and Andromeda will likely experience significant disruptions. The gas clouds in both galaxies will collide, triggering bursts of star formation. This will lead to the creation of new stars, which could alter the cosmic landscape around us. As the galaxies merge, their gravitational influence could push the solar system to a different location within the newly formed galaxy. It's possible that our solar system could be flung into a new part of the galaxy, where it could encounter new regions of space that are different from the familiar environment we know today. In the long term, the merging of the two galaxies will likely cause the interstellar medium, the gas and dust that fills the space between stars, to become more dense. This could increase the likelihood of cosmic events such as supernovae or the formation of black holes. While our solar system might not directly collide with these objects, the increased radiation and high-energy phenomena could affect the planets in ways we cannot yet predict. Our Sun, already nearing the end of its life, will eventually exhaust its fuel and become a red giant. The cosmic environment during the merger could influence the timing and nature of this process, potentially accelerating or altering the eventual demise of our Sun. The dawn of a new era, the new galaxy. As the Milky Way and Andromeda continue their collision, a new galaxy will eventually emerge from the chaos. This new galaxy will likely be an elliptical galaxy, with a more rounded and featureless shape than the original spiral galaxies. The star-forming regions and the dense gas clouds that once defined the Milky Way and Andromeda will become more spread out and diffuse, as the two galaxies lose their distinctive spiral arms and become a single, massive galactic structure. This new galaxy will be a vastly different environment than what we are used to in the Milky Way. With stars scattered throughout the galaxy, the new system will be less organized, and the dynamics of the galaxy will be less predictable. However, the merging of these two massive galaxies will create a highly stable system in the long term. The new galaxy will likely have a much higher concentration of stars, and the formation of new stars will continue for millions of years, fueled by the remaining gas and dust. While the formation of the new galaxy will be a slow process, taking billions of years to fully stabilize, it will mark the end of the Milky Way and Andromeda as individual galaxies. The new galaxy, formed from the collision, will be a symbol of the ever-changing nature of the cosmos. Just as galaxies have collided and merged in the past, so too will they continue to do so in the future, reshaping the universe in ways we can only begin to imagine. The future of the universe, galactic evolution and cosmic expansion. The collision between the Milky Way and Andromeda is not just a story about two galaxies. It is part of a larger narrative about the evolution of the universe. Galactic mergers are a crucial step in the formation of the cosmic structures we observe today, and they will continue to play a key role in shaping the future of the universe. However, the ultimate fate of the universe is much more uncertain. The current understanding of cosmology suggests that the universe is expanding, and this expansion is accelerating due to a mysterious force known as dark energy. As galaxies move farther apart, the universe will continue to grow larger and more diffuse over time. In the distant future, the universe may reach a state known as the heat death, in which all stars burn out, and the galaxies drift apart into an increasingly cold and empty expanse. Despite this eventual fate, the collision between the Milky Way and Andromeda will mark a critical chapter in the ongoing story of the universe. It is a reminder of the dynamic, ever-changing nature of the cosmos, a universe that is constantly evolving and reshaping itself in ways that are beyond our current understanding. What we can learn from the Milky Way-Andromeda collision. While the collision between the Milky Way and Andromeda is still billions of years away, studying this event gives us valuable insights into the nature of the universe. By examining how galaxies interact, we can better understand the forces that shape them and the processes that govern their evolution. The Milky Way-Andromeda merger is a natural experiment on an unimaginably large scale, one that provides us with a rare opportunity to observe the dynamics of galactic collisions in real time. Furthermore, the study of galactic mergers helps to refine our understanding of dark matter, the unseen force that makes up most of the mass in the universe. As the galaxies merge, the distribution of dark matter will play a critical role in shaping the outcome of the collision. By observing these events, we can learn more about the nature of dark matter and its impact on the cosmos. In the grand scheme of things, the Milky Way-Andromeda collision is just one chapter in the story of the universe. The universe is full of mysteries and unknowns, and as we continue to explore and observe the cosmos, we will uncover new truths about the forces that govern the universe and the future of galaxies, stars, and even life itself. As we look ahead to the eventual collision between the Milky Way and Andromeda, it's important to understand that this event is only a small part of the larger picture of galactic evolution. The universe itself has been in a constant state of flux since the Big Bang, and the future of our galaxy and its neighboring galaxies will follow the same inevitable path of change. The Milky Way-Andromeda merger is a testament to the forces at work that have shaped the universe into what we know today, and will continue to shape it for billions of years to come. The role of dark matter and dark energy in the galactic collision. When discussing galactic mergers, it's impossible to ignore the significant influence of dark matter and dark energy. While these mysterious substances are invisible to our instruments, they make up a large portion of the mass and energy in the universe, affecting the gravitational interactions between galaxies. In the case of the Milky Way and Andromeda merger, dark matter will play a crucial role in shaping the collision's outcome. Dark matter is thought to be a form of matter that doesn't interact with electromagnetic radiation, meaning we can't see it directly. However, its gravitational effects are observable, as it helps to bind galaxies together. Both the Milky Way and Andromeda have vast halos of dark matter surrounding them. When these two galaxies collide, their dark matter halos will also interact, causing complex gravitational effects that will further influence the merging process. In fact, many scientists believe that the majority of the mass involved in the collision may come from dark matter, not the visible stars and gas clouds we can observe. Dark energy, on the other hand, is the force responsible for the accelerating expansion of the universe. While its exact nature remains a mystery, it is believed to be responsible for the large-scale expansion of space. However, dark energy has little direct effect on the dynamics of individual galactic mergers. As the Milky Way and Andromeda collide, dark energy's influence will likely remain negligible on the local scale of these galaxies, but its presence will continue to shape the overall expansion of the universe, which may affect the long-term future of galactic mergers beyond our own. Gravitational waves, the aftermath of a galactic collision. One of the most fascinating phenomena that could arise from the Milky Way-Andromeda collision is the creation of gravitational waves. Gravitational waves are ripples in space-time caused by the acceleration of massive objects, and they are predicted to be generated by events like galactic mergers and the collision of black holes. The merger of the Milky Way and Andromeda will be a cataclysmic event, with stars and gas clouds being flung in all directions by the immense gravitational forces at play. These interactions will likely create powerful gravitational waves that will ripple through space-time. While these waves will be incredibly faint by the time they reach Earth, their detection could provide valuable insights into the dynamics of galactic mergers. In recent years, scientists have been able to detect gravitational waves generated by the collision of black holes and neutron stars. The merger between the Milky Way and Andromeda could potentially generate gravitational waves that would be detectable by future space-based observatories, offering a unique glimpse into the violent processes that occur during galactic collisions. In fact, future gravitational wave observatories, like the proposed LISA, Laser Interferometer Space Antenna, could be instrumental in studying the final stages of the Milky Way-Andromeda collision. By observing these waves, astronomers could gain a deeper understanding of how galaxies merge and how massive objects interact under extreme conditions. The fate of the Milky Way's supermassive black hole. At the heart of the Milky Way lies a supermassive black hole, known as Sagittarius A*, which has a mass equivalent to about 4 million times that of our Sun. This black hole plays a crucial role in the structure and dynamics of our galaxy. During the collision with Andromeda, the fates of the supermassive black holes at the center of both galaxies will be one of the most intriguing aspects of the event. As the two galaxies merge, their central black holes will likely begin to orbit each other, drawn together by their mutual gravitational pull. Over time, these black holes will spiral closer and closer, eventually merging into a single, larger black hole. This process, known as a black hole merger, is an area of active research in astrophysics. The merger of these supermassive black holes will generate an enormous amount of energy, releasing it in the form of gravitational waves and potentially even high-energy radiation like X-rays. The final result of the merger will be a new supermassive black hole at the center of the combined galaxy. This new black hole will likely be more massive than either of the original black holes and could have a profound impact on the surrounding environment. The merger of supermassive black holes is not an uncommon event. In fact, astronomers believe that most large galaxies, including Andromeda, likely contain supermassive black holes at their centers. These black holes play a key role in regulating the growth and evolution of galaxies, influencing the formation of stars and the distribution of matter. Understanding the dynamics of supermassive black hole mergers is essential to understanding the overall evolution of galaxies like the Milky Way and Andromeda. Stellar evolution, the death of old stars and the birth of new ones. Another fascinating aspect of the Milky Way-Andromeda merger is how it will influence the life cycles of the stars within the two galaxies. The collision will trigger massive bursts of star formation, as the gas clouds within both galaxies collide and compress, creating the conditions needed for new stars to be born. This process is known as starburst, and it could lead to the creation of many new stars in the newly merged galaxy. However, this increase in star formation will be short-lived. After the merger is complete, the gas supply for new stars will be exhausted, and the galaxy will enter a more stable phase. Many of the stars formed during the merger will be short-lived, burning out in a few million years, while others will evolve into red giants or supernovae. As older stars die, they will scatter their material across the galaxy, enriching the interstellar medium with heavier elements that will be incorporated into future generations of stars and planets. The death of old stars and the birth of new ones will continue for billions of years after the merger, contributing to the evolution of the new galaxy. Eventually, the newly formed stars will reach the end of their life cycles, and the galaxy will enter a period of relative quiet. This cycle of birth, death, and rebirth will continue for eons, shaping the future of the galaxy long after the Milky Way and Andromeda have become one. The end of an era, the future of the local group. The collision between the Milky Way and Andromeda will mark the end of an era for the local group of galaxies. The local group is a collection of galaxies that includes the Milky Way, Andromeda, the Triangulum Galaxy, and dozens of smaller satellite galaxies. As the two largest galaxies in the local group collide, the smaller galaxies will be affected by the gravitational forces at play, potentially being absorbed into the newly formed galaxy or being flung out into intergalactic space. The dynamics of the local group will be dramatically altered by the collision between the Milky Way and Andromeda. The group will become more chaotic, with galaxies being pulled in different directions by the gravitational forces generated by the merger. Some smaller galaxies may be completely absorbed into the new galaxy, while others may be ejected into the vast expanse of intergalactic space. The changes in the local group will be just one example of the larger forces at play in the universe. Galactic collisions like the one between the Milky Way and Andromeda are part of the ongoing evolution of the universe, contributing to the formation of new structures and the redistribution of matter across the cosmos. While the future of the local group is uncertain, one thing is clear: the Milky Way and Andromeda merger will be a key event in the ongoing story of the universe. The cosmic future, the fate of the universe. While the Milky Way-Andromeda collision is a fascinating and important event, it is ultimately just one chapter in the larger story of the universe. The future of the universe itself is an even greater mystery, and the collision between two galaxies is just one part of the grand cosmic scale. Over the next few billion years, the universe will continue to evolve, with galaxies merging, stars forming, and cosmic structures shifting in ways we cannot yet fully understand. In the far future, the universe is expected to continue expanding, driven by the mysterious force of dark energy. As galaxies move farther apart, the universe will become increasingly diffuse, with fewer and fewer interactions between galaxies. The stars in the universe will eventually burn out, leaving behind white dwarfs, neutron stars, and black holes. Over time, the universe will cool, and the energy available for further cosmic activity will dwindle. Despite this eventual fate, the Milky Way-Andromeda merger will stand as a testament to the incredible dynamism and complexity of the universe. The collision of these two massive galaxies is a reminder that the cosmos is not static. It is constantly changing, evolving, and reshaping itself. And as we continue to explore the universe, we will uncover new mysteries and gain a deeper understanding of the forces that drive this ever-changing cosmic dance. As we continue to explore the future of the universe and the long-term consequences of the Milky Way-Andromeda collision, it's important to recognize that this event is just one part of an even bigger picture. The universe, as vast and incomprehensible as it may seem, is constantly evolving, and the future of our galaxy will be deeply intertwined with the larger cosmic processes at play. The merger between the Milky Way and Andromeda might be the defining moment of our galaxy's future, but it's only one stage in a series of galactic events that will stretch across billions of years. The impact of the collision on the solar system. One of the most compelling aspects of the Milky Way-Andromeda collision is the potential impact it could have on our own solar system. While the stars themselves are separated by vast distances, the gravitational forces at play during a galactic collision are so immense that they could disrupt the orbits of stars, including our own Sunday. However, contrary to popular belief, it's unlikely that Earth will collide with another star during the merger. The vast distances between stars mean that direct star-to-star collisions are exceedingly rare, even during such a catastrophic event. Instead, the solar system may be subject to a range of indirect effects that could have a profound impact on life on Earth. As the Milky Way and Andromeda galaxies interact, the gravitational forces exerted by the massive black holes at their centers will affect the orbits of the stars and planetary systems within both galaxies. While the Sun may remain in its position within the new galaxy, the movement of nearby stars could change the dynamics of the solar system. It's possible that the gravitational influence of the merger could disrupt the Oort cloud, a distant region of icy objects and comets that surrounds the solar system. The Oort cloud plays a significant role in determining the trajectory of comets, and a disturbance could potentially send more comets toward the inner solar system, increasing the likelihood of impacts with Earth. While the chances of a major collision with Earth are still extremely low, the merger could lead to an uptick in cometary activity over time. Another consequence of the merger could be a shift in the overall stability of the solar system. The movement of stars and the redistribution of mass within the newly merged galaxy could change the gravitational interactions between the stars and planetary systems, which might slightly alter the Sun's orbit. While the impact of these changes would likely be minimal, It's possible that such alterations could affect the conditions on Earth, potentially altering the climate or causing other long-term changes. Beyond the physical effects of the collision, the Milky Way-Andromeda merger also raises intriguing questions about the future of life in our galaxy. While humanity may not be around to witness the full extent of the merger, our descendants, if we manage to survive and thrive on Earth, could be impacted by the broader galactic changes. These shifts could change the way our solar system interacts with the rest of the galaxy, influencing the cosmic environment that shapes the evolution of life. The emergence of a new galactic structure. As the Milky Way and Andromeda galaxies collide and eventually merge, the final result will be the formation of a new, elliptical galaxy. This galaxy will likely have a much different structure than either of its progenitors, as the gravitational interactions between the two galaxies will lead to a reshaping of the overall galaxy's morphology. The merged galaxy, often referred to as Milkomeda or Milkomeda galaxy, will have a much more spheroidal shape than the current spiral structure of the Milky Way. The transition from two spiral galaxies to an elliptical one will have profound consequences for the future of star formation in the newly merged galaxy. Elliptical galaxies are generally characterized by older, redder stars and a lack of ongoing star formation. This contrasts with the Milky Way and Andromeda, which are both currently in the midst of active star formation. Over time, as the merger proceeds and gas supplies are depleted, the rate of star formation in the new galaxy will slow down, and the population of stars will become more aged. Despite this, the merger will likely trigger bursts of new star formation in the initial stages. The compression of gas clouds during the collision will provide the necessary conditions for new stars to form. However, as the two galaxies settle into their new shape and dynamics, the rate of star birth will decline, and the galaxy will eventually transition into a phase where stellar evolution slows down. The larger galactic structure of the new Milkomeda galaxy will also influence the movement and behavior of stars within the galaxy. Over time, stars that were once part of the Milky Way or Andromeda will find themselves in new positions within the galaxy. Some may orbit the galactic center, while others may be ejected into intergalactic space. The overall dynamics of the galaxy will evolve as the stars and gas clouds settle into their new positions, contributing to the ongoing reshaping of the galactic structure. The fate of other nearby galaxies. While the Milky Way-Andromeda collision will be the most dramatic event in the local group, the effects of this merger will also extend to other nearby galaxies. The Triangulum Galaxy, currently the third largest member of the local group, will be affected by the gravitational pull of the newly merged galaxy. While it's unclear exactly how Triangulum will interact with the new galaxy, it's likely that it will either be absorbed into the larger structure or undergo a significant gravitational interaction that will reshape its own morphology. Additionally, smaller galaxies within the local group, like the Magellanic Clouds, will be drawn into the gravitational influence of the merged Milkomeda galaxy. These galaxies, which are currently in orbit around the Milky Way, could be pulled in or disrupted by the merger, leading to further changes in the local cosmic environment. The local group itself could experience significant changes in its overall structure as the merger of the Milky Way and Andromeda ripples through the surrounding galaxies. The gravitational forces from the collision could rearrange the orbits of the galaxies within the local group, potentially leading to further mergers or interactions in the distant future. In this way, the Milky Way-Andromeda collision will be part of a larger ongoing process of galactic evolution that extends well beyond our own galaxy. The future of galactic mergers. Looking even further ahead, the merger between the Milky Way and Andromeda is just one of many galactic mergers that will shape the future of the universe. As galaxies continue to collide and merge, the structure of the universe will evolve in ways we can only begin to understand. While the Milky Way-Andromeda collision is a relatively small event on the cosmic scale, it is a key moment in the ongoing process of galaxy formation and evolution. The fate of galaxies in the distant future will be influenced by many factors, including the expansion of the universe, the influence of dark energy, and the gravitational interactions between galaxies. In the long term, the universe may become a more isolated and diffuse place, with galaxies becoming increasingly distant from one another. However, in the nearer future, galaxy mergers will continue to shape the landscape of the cosmos. Eventually, all the galaxies in our local group could merge into a single, massive elliptical galaxy, a process that could take billions of years to unfold. The larger structure of the universe will continue to evolve as well, with dark energy driving the expansion of space and influencing the fates of galaxies across the cosmos. As we peer into the future, we can only speculate about what the universe will look like billions of years from now. But one thing is certain: the Milky Way Andromeda collision will be a defining moment in the story of our galaxy and a key chapter in the ongoing evolution of the universe. Whether it's the birth of new stars, the death of old ones, or the merger of supermassive black holes, this collision will leave an indelible mark on the cosmic landscape. As we continue to look forward to the long-term effects of the Milky Way Andromeda collision, it's important to remember that cosmic events of this magnitude have far-reaching consequences for both the immediate future of our solar system and the distant future of the universe. While many of the impacts may seem far off and abstract, the collision between these two massive galaxies presents a dramatic shift in the balance of our galactic neighborhood. It's an event that holds more than just curiosity. It will be a crucial part of the unfolding cosmic drama. The role of supermassive black holes in the collision. One of the most fascinating aspects of the Milky Way Andromeda collision is the role that supermassive black holes will play in the merger. Both galaxies are home to supermassive black holes at their centers, with the Milky Way's black hole, Sagittarius A*, containing about 4 million times the mass of the Sun, and Andromeda's black hole, known as M31's supermassive black hole, being similarly massive. As the galaxies approach one another, these black holes will begin to influence the dynamics of the collision on an entirely different level. When two supermassive black holes collide, the result is a cataclysmic event that sends ripples throughout spacetime, gravitational waves. These ripples are detectable by advanced instruments like LIGO, Laser Interferometer Gravitational Wave Observatory, which has already observed similar, albeit smaller, collisions in other parts of the universe. The merger of Sagittarius A** and the Andromeda black hole will be an event so intense that it could provide invaluable data for astrophysicists studying black hole physics and the nature of gravity itself. But the immediate effect of this collision will be far-reaching. As the two black holes spiral towards each other, they will interact with the gas and stars surrounding them, drawing in material from their environments in a process known as accretion. This process will likely trigger intense bursts of radiation, particularly in the form of X-rays, as the gas is heated to extreme temperatures before being consumed by the black holes. These bursts of energy could significantly affect the structure of the newly formed elliptical galaxy, influencing star formation and the distribution of matter across the galaxy. Additionally, as these supermassive black holes merge, their gravitational influence could disrupt the orbits of nearby stars, potentially throwing them out of the galactic center or even sending them into hypervelocity orbits, where they would escape the galaxy entirely. The gravitational wave event itself will also provide an entirely new way of observing the universe, one that could reveal deeper insights into the fundamental forces of nature, the fabric of spacetime, and the formation and growth of galaxies and black holes. The long-term evolution of the new galaxy. Once the merger of the Milky Way and Andromeda has completed, the result will be a massive, sprawling elliptical galaxy, much different from the spiral structure that defined both of its predecessors. This new galaxy, often referred to as Milkomeda or simply the Andromeda-Milky Way merger, will likely take billions of years to fully settle into its new configuration. While elliptical galaxies are typically characterized by their older stellar populations and lack of ongoing star formation, the initial stages of the merger will likely trigger a brief period of intense star birth. As the gas clouds from both galaxies collide, they will compress, triggering new rounds of star formation. However, once this gas is used up, the rate of star formation will decrease dramatically, and the galaxy will enter a more stable phase. The result will be a massive elliptical galaxy filled with older stars, many of which will be on highly elliptical orbits around the galactic center. During this period of galactic evolution, the dynamics of the galaxy will continue to shift. Stars from the Milky Way and Andromeda will settle into new orbits, and the remnants of the two galaxies' spiral arms will be absorbed into the new elliptical structure. This process will likely take billions of years, but eventually, the galaxy will become a more homogeneous and stable entity. The newly formed galaxy will likely be filled with stars that are no longer actively forming, and it will be relatively quiet in terms of new cosmic activity. However, even as star formation slows down, the black holes at the center of the galaxy will continue to be a source of intrigue, potentially growing even more massive as they consume the remaining gas and debris within the galactic center. A galaxy for the distant future. While the Milky Way-Andromeda collision will be a momentous event for the current generation of life on Earth, it is important to recognize that this event, like all cosmic phenomena, is part of a much longer timeline. Humanity's current understanding of the universe and its history is shaped by the past 13.8 billion years since the Big Bang, but we are still only at the beginning of understanding the long-term fate of the universe. The collision of the Milky Way and Andromeda will mark a major milestone, but it will not be the end of cosmic evolution. Over the next several billion years, the newly formed elliptical galaxy will continue to evolve. With star formation slowing down, the new galaxy will likely enter a phase where the existing stars grow older and die off. However, there will still be remnants of the old spiral galaxies, gas clouds, rogue planets, and black holes that will continue to reshape the cosmic landscape. As the universe continues to expand, the energy available for creating new stars will diminish. The universe will gradually grow darker as galaxies begin to run out of the raw materials needed for star formation. This degeneration phase will mark the eventual decline of the universe's ability to produce new stars and galaxies. Yet, even in the face of such a quiet, dark future, the Andromeda galaxy will remain a testament to the explosive and dynamic history of the universe. The legacy of the Milky Way-Andromeda collision. The merger between the Milky Way and Andromeda is an event that transcends time. It represents not only the future of our own galaxy and solar system but also offers us insight into the larger processes at play throughout the universe. By studying this cosmic collision, we learn more about the forces that shape galaxies, the processes of star formation, and the ultimate fate of our universe. Even though we won't be around to see it, the collision will have lasting consequences for the structure of the universe. Over time, future civilizations, or the remnants of intelligent life, may look back on the legacy of these galactic events and study the final moments of a universe that was once filled with active stars, powerful black holes, and the fundamental forces of nature. As the universe continues to evolve, the story of the Milky Way-Andromeda collision will be an essential chapter in understanding the vast complexity of cosmic dynamics. While humanity's place in the galaxy is fleeting, the Milky Way and Andromeda's encounter will remind us of the vast, unpredictable nature of the cosmos. We are living through a moment in cosmic history, and even as we look up to the stars, we are reminded that the universe itself is in constant flux. From the merger of galaxies to the birth and death of stars, everything in the universe is connected in an intricate, ever-changing web. The Milky Way-Andromeda collision will, in a sense, be the beginning of the end for our galaxy. But it will also mark the beginning of something new, a new galaxy, new dynamics, and a new cosmic era that will unfold in the distant future. And while we may never see the final outcome, the story of this galactic collision will continue to captivate our imaginations, serving as a reminder of the incredible scale and beauty of the universe. This video is for educational or entertainment purposes only, and information provided in the video may be incorrect. Like the video and subscribe to the channel for more such amazing videos.